All right, we're going to get ready with the next talk. So we have, oh, sorry, y'all. We're getting ready for the next talk. But Alex Curtis is going to be talking about insecure lab environments and learning with them. So please give him a warm welcome.
Thank you. Hope you all doing having a great day today. Super excited to talk about insecure lab environments with you all. Hope you are all super excited to hear about them. So this is something that I just find very fascinating myself. I love working on it. I love doing it a lot. And that's the idea of building vulnerable lab environments. And a little background here. So I am a security consultant at Leviathan Security Group, same as Josh, who gave the awesome car hack talk earlier today. And for the last 4 years or so, I've been doing industry training. Before Leviathan, I worked at Twitter, so that was all internal developer training for them. I've also done just some external stuff working for consultant companies, going out and trying to do like software development lifecycle talks. And also I teach an intro security class here at CU. It's the introduction to cybersecurity. So there's a lot of talking, a lot of teaching, a lot of demoing, a lot of that kind of stuff. And one thing that helps more than anything else in any kind of presentation environment is having some kind of vulnerable lab environment or some kind of demo. And by vulnerable lab environment, I mean something that is meant to be broken into a test space where people can play around with and break into whatever it is that they are learning about. So some examples here, hack this site, hack the box are super common ones that you might have used yourself. There's a bunch of capture the flags that people make. These get integrated all the time in like conferences and just as learning tools normally. And oftentimes they show up in demos and talks and presentations, that kind of thing. This is by far the #1 best way of increasing the productivity of a talk and actually making it worthwhile. There's a few reasons for this. The first one is they're very informative. For nearly every computer science discipline, it's always more useful to actually have hands-on ability to play around with and manipulate whatever it is you're learning about rather than just seeing it on a screen in front of you, which is normally not nearly as helpful. And this is especially difficult to get for security because there's all those pesky laws that prevent you from just like going out and trying to hack on random sites on the internet. You can't just go off and explore cross-site scripting to your heart's content. You have to do that in very specific environments or else that's illegal. It's also much more realistic to do it that way. If you have some actual environment where you can play with and see the results of whatever security thing you are doing in action, normally that's kind of how we do it in real life. We don't have some like check the box as to which of these is actually SQL injection and which one doesn't work. That is not what any of us do in our day-to-day. So it is just more realistic, more educational, and most importantly, it's more fun. No one likes to just sit there and be told, here's how to do the cool hacker thing. We all want to do the cool hacker thing and be the cool hacker. So it increases engagement. People just absolutely love it. If you can work this into a presentation, you absolutely should. However, this can be kind of difficult for a few reasons. #1 being you are trying to build an environment that is actively able to be exploited. You're trying to build something which has a security flaw so that people can learn how these security flaws work. And this can be hard. You kind of have this spectrum of how insecure something is. So on one side, you've got, you can't actually interact with it, like they don't have permissions or it's not really an interactive environment. I would say just a slideshow is on the, you don't have permission to interact with it side, but just because it's a slideshow, it's not actually something you can interact with. On the other side of the spectrum, you have complete interactivity. Someone can break in, hack through all the passwords, get root, dump the database, whatever. Just get full access to whatever environment it is that you are demoing. That is really cool, but comes with its own challenges. So for the low level of permissions, that's just really boring. At that point, if someone can't actually interact, they can't get data, they can't break and enter into whatever system it is, you might as well just give a talk, and talks are boring. And the irony of me saying that right now is not lost on me. However, if you can make it interactive and interesting and have people work on whatever it is you're doing, then you hit this fun, nice sweet spot where people can actually experiment and can try new things out, maybe try things that you aren't even explaining, just see if it works, so see if they can do it. They can try and fail, which is a good learning exercise. They can try and succeed, which feels good. There's just all kinds of things that people can do if they're given the ability to actually interact with it. But then there is going a little too far, and that's the zone where suddenly they actually do just get root to your demo, and then they destroy your demo and everything goes bad. I did not think this zone existed at first. The very first time I tried this, we were talking about privilege escalation, and I thought, you know what would be fun? If I just set up a little site where people could go and escalate privilege in exactly the ways that we're discussing in lecture. This was for one of those CU classes. And so as I'm talking about it, maybe people can like try it out themselves, escalate, and by the end they could actually get root on this little machine. It was just a virtual machine in the cloud, so no harm if they get root. There's no actual damage they could cause. I guess like they could like take down the lab or something. They could like change the password, but there's not really any reason to do that because this isn't your typical adversary-victim relationship here. We're all on the same side. We're all just here trying to learn. That was very naive and I should have known. So immediately what happened is after someone escalated to getting root, they deleted the Etsy folder, just deleted /Etsy for the reason of, and I quote, they wanted to see what would happen. And that seems like a failure, but actually that proves that this is actually very successful. They were experimenting. They were trying something new. They were like, what happens if I delete the very important system files and all the user passwords? And they found out it was actually a really good learning exercise for them. It's a good learning exercise for me. And it was even a good learning exercise for the rest of the class who had no idea what just happened other than as suddenly they can't log into the demo site anymore. And so we actually had a bunch of people come up afterwards and start asking like, what just happened? Why did that go down halfway through? And that became just a good way to talk about, oh, here's some interesting system files. Here's where you store the passwords on Linux. We weren't going to talk about that, but that is something very important. And now everyone got to know about it. So there is an actually good exploration zone there where people can try new things and just have a lot of fun if they're given the right guardrails to not accidentally destroy everything. And if they feel comfortable not accidentally destroying everything, then they will experiment and have fun, that kind of thing. Now, this is the main objective, is to hit that little good experimentation zone there, but we have two side objectives as well that I'm gonna throw in here. So our bonus side quests, we are not made of time or money. While it would be more realistic to spin up an entire production environment with like a CI/CD pipeline and web service databases, this is for like probably an hour-long talk. We don't have the months or years to actually spin that up, but we might be able to cheat it. We'll get to that in a second. So we do want to make sure that the stuff we're building here is quick and easy to build and deploy such that we can actually work it into a presentation without breaking our cloud budget, without breaking our time budget for actually preparing for things. It should just be equivalent to a fancy slideshow. It's something you have to put together, but you can do it real fast. I also would like these things to work for multiple people. This is more of a personal goal, but nearly every talk I give is to more than one person, and especially in a classroom environment, you normally have up to like 200 people collaborating in tandem, and they all need to be able to access the same thing. So having like some way for everyone to interact and just have it be a good group activity, I find that very important. So some of these tips are going to be specifically how to get that group work going. So how do we allow interactivity into this kind of environment? And I'm going to start off with an example. Has anyone seen this site? It is the Google XSS game. A few people. This is fairly common. I know I was shown it as a young stud. This is Google's way of trying to teach people about cross-site scripting. So they say, oh, here's some cool things about like cross-site scripting or bugs that are bad, and we'll pay you if you find them, and we're Google, and we just are cool enough to make this a publicly available training thing. Your mission, should you choose to accept it, is to inject a JavaScript alert. So that is their training method, is see if you can inject malicious JavaScript into this example web page. I'm guessing at least one person here could figure out how could we inject a malicious JavaScript payload that alerts into this. Any guesses? You could just shout it out. Script alert. Yep. Oop, doop, 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 doop. Nope. Hit enter too fast. Script alert, and then if you actually close it. Yes. So yay, we popped up an alert by injecting JavaScript. If you don't know what just happened, just Google XSS. It's actually not too crazy. And they have a few levels of these, so you can then try it again. And yes, hello, I know. So the next one is like, you've got a little chat forum and can you do it here and whatever. So this is my example because not only have I seen it, most people have probably seen it if you've studied web security, but it's also a very good middle of the road example of what these demos generally look like. I would say this is very par for the course. Let me know if you agree or disagree, but I feel like any time that I see an interactive demo that is meant to be breakable, it's pretty equivalent to this in just general feel, general vibe. So my question for you is if it's pretty similar to that, let me bring up the slides again. Was that vulnerable enough? Was that like a good learning exercise? Was there anything that could be done better? Yeah, just shout it out.
I think it's good in that it was like a real attack, right? So you did what the attacker would do, but I think it's not, it could be more compelling if the students felt like it was a real website.
Yeah, so it's good. It does show how to do an XSS attack. I know we just breezed through it. If you don't know how to do an XSS attack, just go to the site. But it does tell you the technical details and lets you experiment there. But it does miss a lot of key context. And like you were saying, it doesn't really feel like a real website. Specifically, here are just some things I would prefer it had. There's no actual impact here. There's no data to steal. There's no harm that could be caused. You're popping up a JavaScript alert, and that is their stated goal. So the whole intro paragraph they give you about how these are terrible bugs and they happen to Google all the time. Well, I just made a JavaScript alert on my own computer, and that really was not that bad. So that also means that the severity of whether or not this is even bad is really unclear. There's no harm that could be caused. So a big part of our job as security engineers is to figure out, is this actually worth fixing? If someone said that that was the only thing that could happen, someone could pop up an alert on their own computer, I don't care. That is not worth my time. So it does muddle the idea that they're trying to convey here, which is that this is a serious security issue. There's also a few other, these are mostly nitpicks, but there's no recon. They just say like, here is the box, type it in here. Normally that's the biggest part, is figuring out like which box do you type it into. I know that's a major understatement, and then also it's not a good group exercise. If you have like a bunch of people doing this, they're all just doing it themselves. They're not like, each one just has it up on their own computer. They're like, yay, I made a pop-up on my own computer. Maybe they turn the computer around to show you if they're proud. So it's just not as realistic and enjoyable as I feel it could be. So how can we make that more interesting? The number one way I found to just really quickly add an easy boost to a lab exercise, just throw everyone in the same environment. So here's my take on this. And this is actually public if you want. The site is hackthisdemo.com. But similar kind of thing, just like mini Reddit site, whatever. You can create a post, and this is also XSS, accessible. Whatever you put in the content here will do XSS. And that makes it really easy because it's actually a shared environment. If anyone goes there, you will see these things, these various posts. You can make your own post. Make your own post right now, and I will click on it and see what happens. That's a threat, by the way, like go for it. And then the nice thing about this is if you have a bunch of people all in a room together like this, or like any kind of presentation demo, this works great in class because like they're zonked out, they're on their laptops, but this is an opportunity to like screw with their classmates. So suddenly everyone's paying a lot of attention. Suddenly this becomes a shared environment where not only are we trying to just figure out like, what is this whole XSS thing, but these questions of how can we extend this? What could we do with XSS? So there's the like simple, here's someone put this alert script into the body, yay. But then people will also do, nice. People also do fun stuff like this where you'll click it and suddenly you get rickrolled, which is always great. I love it when that happens. But people will start to experiment and they'll see like, what can we do? Could we steal each other's cookies? Could we like impersonate other users? Could we actually do more things? It asks that question of what is the severity of this issue? And it does it in a fun way where people can actually interact with each other. So for basically zero upfront cost, we can actually make this a much more interesting, engaging demo that is pretty much exactly the same thing that we just saw with the do it yourself, only you're not doing it yourself on your own computer, you're messing with other people. And this only kind of works because it's the web. and the web is like super sandbox. It's not like you can cause actual harm to other people here. The one caveat is just tell anyone using your demo never to plug in an actual password that they use, because I've had that happen. Just don't do it. But this even works for things like, nice. Very rude. But this even works for things like Linux environments, where if you just put everyone in a big shared Linux environment, suddenly you'll have people using the wall command to just start sending messages to each other and leaving little files. I keep going on to Linux environments that I've set up for these labs, these demos, and you'll just find a text file in the root directory like, John was here, and you just find like a bunch of people have signed it. It's like, John was here, sign below if you've also found this. And that's awesome. People actually start interacting with each other and having fun with it and trying to see like, ooh, how can I just screw with the friend I've got sitting next to me? To the point where even here, I don't know who you are, but you lovely people are just going out of your way to comment on some random thing I set up in 5 minutes. So thank you. So yeah, easy way to build interactivity and allow for that kind of actual exploitation of other people, allow for that kind of faked harm where you could potentially, not in this demo, but in a more interesting one, you could take over someone's user account. You could show what level of harm this vulnerability could actually cause. And that's very valuable. Now, this does raise the question of like, you don't want to go set up like a fancy multi-user service every time you want to do a presentation. That takes time. That violates our rule if we are trying to do things quickly and easily. So this was actually a test here of what is the quickest site that I could make in 5 minutes using ChatGPT. ChatGPT is not good at writing big production code, but it is really good at writing small, easy snippets that you can throw up as a live demo. And so that literally was, in 5 minutes, what is the most I can get? That includes testing. It included everything except for deployment, was exactly what you just saw. And it worked. Even if ChatGPT includes some like extra security vulnerabilities you didn't notice, oh no, too bad. Your vulnerable lab environment is more interesting. And I've done this a few times. Here's like a chat app. I wanted like a real-time chat app. I've tried writing those myself with like Socket.io. It sucks. I don't understand it. It scares me. ChatGPT just made it work immediately, first try. So if you do just want to throw something up real fast, just go to ChatGPT and ask it for whatever you're looking for. A couple tips that I found that make this easier and generally get better results. First, do not ask it for a bunch of features all in one prompt. ChatGPT is dumb. It has no memory. It will only do like the first thing you ask it. But it is good if you make the website I just put up and you're like, oh, I actually want user accounts. Have it generate the base site and then say, now can you add user accounts? Now can you add an SQLite database? Now can you add this? And if you keep asking it for iterative prompts, it does better than if you give it all the features all in one big thing. Another tip, if you mention a CSS library, Bootstrap is a popular one. I prefer Bulma. It's just like a fun CSS only library. Then it'll just make everything look nice too. So I didn't do any CSS either. It just looked like that. If you don't specify that, it'll just be raw HTML and everything will look like garbage. So quick, easy way to get some interaction, make things more interesting. If you don't want to pit all of your users in a cage match against each other, you can sandbox it a bit better. One thing that I found has worked kind of well, this is specifically just for the web, but I feel like it saved my ass enough that it's worth mentioning, is Selenium is like a web driver thing. It's used for testing web apps. So you can, it'll like open a browser and you can say, hey, click on this button, now click on this. And it's used for front-end designers to make sure that their website still works. We can use this if you want to add like fake user interaction that is still real enough to have like cookies and run JavaScript and stuff, so you can do XSS attacks. It's pretty fast. Here's the lines of code that I use in a demo I've got, where basically I just, you can see it spins up a WebDriver that runs Firefox, and then I can tell it to get a particular URL. And the only thing that happens in between there is I tell it to set a particular header, authentication header, so that it does that as a particular user. And what I've done with this is, I don't want you anymore, I want you. This was the final exam for that computer science course. And one of the things was there was cross-site scripting that was part of the class, and I wanted that to be part of the final too. But I couldn't just pit everyone against each other in the final. So instead, there was like this little Cash App type site where you could send money to each other. And it included a support link. And the support staff member was my friend Johnny Link Clicker, who would go, and if you sent him any link, then he would click on it. And what's happening here in the background is, can probably get these to be separate. There's actually a, Johnny Link Clicker is running one of these web browsers. Don't mind me. I'm just losing the entire control of my computer. So this is going on in the background. It's just that Selenium bit of code that I showed you before. This is an actual web browser. It doesn't have anything loaded right now, but if we tell, in this case, any text message to this chatbot that included a link, they would click it. So if I said, go to google.com, you can see in the browser, it actually opens google.com. And so the idea here is, there was a whole cross-site scripting component to it. So you could get the support staff to actually click links using cross-site scripting, and they would actually load up in a browser and do that whole thing. So fun way of doing that if you don't want to have everyone be in the same environment. However, I would not say that this checks the box for super easy and fast to deploy. This actually took a little effort. But if you don't want that high interaction demo where like bots will also click links and stuff for you, might be worth doing. Another tip though, if you want like complete sandboxing, everyone is on their own, individual, but still like you don't want to spin up like 40 different websites if everyone's going to be on their own one. You don't want to deal with like sandboxing stuff. The cheapest, stupidest hack I found, which is also super easy to do, just change the database for every user. And you can do that with SQLite. So SQLite is not like most databases that have an actual server. An SQLite database is just a single file on your computer. And fun fact, you can, in most frameworks, just tell it to switch that file dynamically every single request. So I had one of these labs where just there was a whole database full of files. Each file was a different database. And that way, anytime a user went to the site, it would load up their particular database, meaning everyone was separated. And so each user got their own version of the site, even though it was only running like one web server, one site, one box. Everyone seemed to have their own instance of it. And it had full, like, there was a full database there. You could even do database injection and a bunch of these actual attacks. And the one line that made it work was just when I got an engine, or when I tried to like make a database connection, I just added the username string directly in to the database thing, which is not normally something you should ever do, but it works. It is not very fast. It is definitely not production quality, but if you just got, this worked for like 200 students. So it works at kind of scale. Don't build your actual product off of this, but you can definitely make a demo off of this. This has actually been super helpful, would recommend. But let's say we want to go a little deeper. We want to actually let people do that whole breaking into the website, getting root access, and doing all that cool stuff. The tool that I have found works better for that than nearly anything else is Docker. So a quick recap for folks who have not used Docker a bunch. Docker is basically a virtual machine, and I'm sure someone in the world would shoot me if they heard me say that, because it actually is completely different in almost every way. But it acts like a virtual machine. So in a virtual machine, you are actually running a second computer inside your computer. So that's on the left there, you've got your host operating system, and inside it, you've got an entirely separate operating system that's then is running your virtual machine processes. In Docker, and in any container sandbox like Docker, although I've only ever worked with Docker for this, you are not running a second computer, you're just running the one. And what it's doing is you're running the process just like any other process on your computer, except the Docker sandbox tells that process that it is the only thing on the computer. So it simulates the file system, it simulates the network stack, it simulates the process list, anything which a process could use to tell like what else is going on the computer. The operating system just keeps 2 copies of that, and we'll send 1 copy to one process and another copy to another process. So at the end of the day, we're not running a second computer, but all of our processes think that they are running on their own separate computers. And we can extend this. You don't have to have 1 process per container. you can split it out. By the way, I've used the word namespace here because that is the official Linux term for this. They are Linux namespaces. So each process in a namespace can only see the other processes in a namespace. They can only see the other files in that namespace, all of that. So we can split up our computer to basically act as multiple different computers. You've got your kind of host processes, which are the main, like that's the computer you think you're using. And all the processes that you're using as an actual person on that computer. And then you've also got a bunch of these Dockerized processes, which all exist in their own namespaces and think that they are the only things running. They think that they are the hosts of their own computers, but they are not. Now, if you ask anyone who actually deals with Docker and builds in a production environment about this, they will say, what on earth are you doing? Please stop, because you are not supposed to normally do this. You can't just treat Docker like a virtual machine. It's not meant for that, but it does a pretty good job. So we can just make it do that anyway. And the reason that we would break Docker in this weird way to like make it act as if it's a virtual machine by having a bunch of processes running in it is because it's really, really fast and it has almost no resource overhead. You are not running a second operating system inside your operating system. And that comes with a ton of savings in every metric that matters when it comes to building these quickly and easily. So yeah, because it's just running another process on your computer, the cost of running a web server in a virtual machine is running an entire separate computer. The cost of running a web server in a container is just the cost of running a web server. And you can run like a few hundred web servers before your laptop crashes these days. Computers are fast. So yeah, super fast, super easy to set up and no resource overhead. The only downside is it does kind of limit you to Linux. Technically, you can run containers on any operating system. Windows has a whole container environment. It doesn't really work. And by that, I mean, the tooling is all there for Linux. All the containers are there for Linux. The Windows environment, while I would love to have like an Active Directory thing set up with Windows containers and just build a whole Windows environment, those containers just are not there. The support in Active Directory is not there. So you are kind of limited to Linux on this. However, that means we can build really big, expansive Linux environments with just Docker containers. So remember at the beginning when I said there's no way you could just like set up an entire production environment just for a demo? Well, we can set up an entire production environment just for a demo. This was a midterm for a class where they had to go break into I say production environment. This would be like you're a small startup who is also from 2005 and has not actually gotten on the cloud yet. But they were running like a VPN, some web servers, a database. They were running a couple user laptops, and just for kicks, I added some CCTV cameras, which, because you can just run Linux, there were just some web servers serving a static like camera feed, but it still looked like a camera feed. It still acted like a camera feed. And you can just set all this up and spin it up. Now, I've got all the code for it here, and if we're trying to spin up, this was, what is that, 9 virtual machines. If we're trying to spin up 9 virtual machines, that would be, that would take forever. Now, if we try and spin this up in Docker, it is still 9 containers, so it might take a couple minutes. So never mind, it's up. There we go. So now we just have 9 virtual machines running effectively. That's all those, the like database, the VPN, all of that. And we just have our own little private environment. So yeah, the upsides, skipped ahead on the slides without updating. There we go. So it is crazy fast. I did time it. It is less than 3 seconds to just bring all of those up. And it's super easy to configure. And I'll get more into the configuration in a second here. But there's, you can kind of see just a snippet of the YAML that makes this possible. If you've never dealt with Docker Compose, you just say like, I want a VPN server running on this port. I want a web server running on this port. And suddenly you have a production environment. And it's stunningly, it can be as easy as that. This also gives you some fun options to distribute this. So normally if you've got a demo like this, traditionally what you'll do is kind of expose some of these containers to the internet. So you'll have like your web server, and that's exposed to the internet so that people who want to participate can access your URL or whatever, just like the demo from before. However, you can also give these out because this runs on a laptop. This runs on a laptop and it's super resource efficient. In fact, we can probably see Docker stats. Oh, that formatting is not helping here, but there we go. I'm actually running a bunch of additional containers here just because it doesn't matter. I can run as many containers as I want, and you can kind of see the memory usage of some of these. So this was all, the network pen test was that environment here, and these are all running in the low megabytes of memory usage. Again, each one is effectively its own virtual machine. So super low resource, super easy. So you can basically hand this out, and pretty much anyone with a laptop can run this, no problem. So I've seen people try and hand these out to just say, like, you want a production environment? Here's the code, just run one command. You saw a second ago, I just ran one command to bring them all up, and suddenly people can access everything locally. And the one that I really like doing for this, and that's the one I did for the midterm, is I mentioned this lab environment contained a VPN server, just like a normal production environment might. Well, guess what? That's a working VPN server, so you can just say, hey, anyone who wants to access this environment can VPN in, and it's effectively like putting yourself into their production network. And that is really cool because suddenly you can do a bunch of network testing and a bunch of actual internal scanning stuff and actually SSHing onto these devices and everything without exposing them to the internet. And so pretty much the way this would go is I could just say, hey, I want to VPN into my little Docker environment. All of those containers are, you can tell Docker just set aside your own private network for them. So now effectively I've just joined a little private network with my little private production environment. And so here we can do a bunch of fun stuff, like I've just got the IP range. So this is just the IP range for my little Docker environment. And we can act as if we just broke into their production time or their production environment and start mapping around, doing exactly what you would in a typical scenario here, and see like, oh, here's the web server, here's, you know, the running telnet, we can abuse that. You can see there's like some web servers, the database server and all that. And then on the web side of things, you can let's see. By being on the VPN, we have access to like the employee portal and all that, which you would normally expect in a production network, but it's behind the VPN. So it's not exposed to the internet, but now that we're in the VPN, we can maybe look around here to see if there's credentials or stuff. So all of these cool things, which normally you could not simulate being able to get into an environment like this, suddenly that all becomes possible just by VPNing into this little Docker network. And of course, this is all superficial. This could be running on the cloud. In this case, I'm just running the whole thing on my local laptop. But yeah, we did this as like a midterm and just had it running on a cloud host, had 200 people like all logging into it and screwing around, trying to break things. And it worked just great. I know there's some concerns about like Docker escapes. It is less sandboxed than a virtual machine. But honestly, unless you're doing anything really crazy with volumes, there's not that much that, like the default settings are fine. As long as you don't actively break it, it's hard to escape from a container if you're not either hella good at what you were doing or the person setting up the container was hella bad. And seeing as we're all security folks here, we know what we're doing. Boy, that's gonna go on my tombstone. But if you just put on a cloud instance where if they break out, nothing matters, I've never had that happen where someone has been able to get out of a Docker environment. For folks who haven't set this up, that midterm thing I just showed you, that was the first time I'd ever used Docker. It's actually really easy to pick up and set up in a fairly easy way, but I'll just walk through the steps to do it real fast here. It makes it really easy to start with a container because normally people just publish a bunch of what are called base images where they've just installed whatever program they want into a container. Sometimes they install multiple programs. So if you just want a database, there's just a database container out there. Which database? It doesn't matter. Any of them work. There's a container for all of them. You want a web server. You want a thing running Python. You just want like Ubuntu. You can just download that as a container and chances are someone has already made it. The added side benefit here is sometimes the people making these containers are not security folks and have no idea what they're doing and will make something like this. So this was actually a tool I was using for a separate demo. It was not it was just, we were talking about PHP injection, and this is a PHP container. It's the first one that comes up when you look up XAMPP stacks. I have only ever used PHP in an XAMPP context, which just stands for like you're running MySQL and PHP at the same time. I don't really know why this jumped into my head, but I'm glad it did, because when I looked it up, the person who made this container also included an SSH server, for some reason, there's actually no reason to include an SSH server in Docker. It's not a virtual machine. You're not supposed to do that. The only reason is if you want to build a intentionally insecure lab environment, you want to have SSH. So this made it even easier to do that. They also mention here at the bottom that both the MySQL and PHP MyAdmin use the default password. So it was just great. This turned into its own security demo, just on its own, accidentally. So finding these, even if they're like not very good, not secure. I know the last presenter was very good about mentioning you should make sure you have secure base images. Well, if you're building an insecure environment, that doesn't really matter that much. I am assuming that you are actually sandboxing these insecure environments, not like, don't run your demo environments that are meant to be broken out of into or in your own like production environment at work. But you already knew that. So yeah, just having stuff like this where it's even easier to break into or break out of this environment just makes it more fun. The next step with any Docker container is to customize it with a Docker file. If you've never used a Docker file, it's a shell script. It's just a fancy shell script. You say like, I want to have these tools, and it'll give you those tools. And you can like set up users and stuff this way. So if I want to have a computer which has like certain users who have bad passwords, this is how I would do it. I just say, hey, here's my users, here are all their passwords, here are the tools that they have installed. You can add files to the system and just make it feel like an actual environment people work in, and just run shell commands to do that. So it's pretty easy to set up an individual machine. So you can use this to really easily just spin up a single device that has all the requirements you need for whatever demo you're doing. Like if you're building a website, you can just really easily install like a server to give it the command to run your website. Or if you want to, in this case, like brute force passwords or escalate privilege or something on a Linux machine, it's really easy to say, okay, we'll add these users. Here will be their passwords, change some file permissions so that suddenly everyone can access the shadow file and that kind of thing. Finally, if you want to network a bunch of them together, there's a great tool for that called Docker Compose. And this was the one I was mentioning where you just say basically what you want to run and which ports they should be on. And you can even specify things like what IP addresses they should have, which of them are networked together. So you can say that like these 3 computers are networked together, these 3 computers are networked separately in their own network, and then there's like a router combining them. You can do that and actually build really crazy complicated network environments if you really want to. For fairly cheap. It literally looks like this, where you're just specifying kind of the runtime configurations of IP address and network information. So it's really easy to actually set up a ton of environments this way, or not a ton of environments, but an environment with a ton of different options and different tools and devices and endpoints and users and all the fun things that you want, but normally would take too long to build. Finally, a couple additional benefits to using Docker for this kind of thing. If someone does manage to break something, you just restart a container. It takes about 3 seconds. So because this isn't a virtual machine environment, because everything's so fast, so easy, resetting things or making changes is super quick, super time efficient, super cost efficient. So, and the whole idea of Docker is that like you can't, you set everything up in configuration files, but then like you write it once, it runs the same every time. So it's really easy to build something where you can just restart it without worrying about everything breaking. There were definitely some times when I would worry something was wrong, so I just restarted the entire environment just in case, because it just works. There's also a fun thing you can do where you can mount files from your host operating system into containers, and you can do this in a read-only fashion. So if you do have some files that you absolutely do not want to change, like you don't want users to be able to set their own passwords, or you don't want certain key files, like if you're building a capture the flag and you have a flag file, but you don't want users, you want them to read that file but not be able to edit it, but you still want them to like gain privileges where they could edit it or whatever. Just in case, you can mount this is actually, the command there does not imply the thing that it shows, because that's a typo on the slide. But you can mount things as read-only, and this is borked because it does not include the read-only flag on that mount, but it would be just putting a :RO for read-only at the very end of that bit about Etsy Shadow. That's embarrassing. But yeah, you could mount things as read-only so that suddenly certain files, including important system files like Etsy Shadow, or just files that you want on the device because they're part of whatever demo or lab you're doing, do not get modified, you can just mount them as read-only, and then not even root can modify them. So yeah, fun little things you can do there, only because Docker has reduced or is like more entrenched with your host operating system than a full virtual machine. So yeah. I feel like this is a super good tool. I plan on using it in the future anytime I have any demo where people can get down to the operating system level, or if I just want to demo something at the operating system level in a sandboxed way. However, as far as I can tell, no one really does this. The only other person or group that I've found online who has built out any amount of training material using Docker rather than VMs is the Naval Postgraduate School. They have a whole process called Labtainers, which is their version of this, where they just have a container environment, or I guess like a lab environment done with Docker containers. So if you do want to see some examples of people doing this who are not me, they actually have, like, I want to say 50 or so different lab environments of varying levels of complexity. Some of them are like DNS resolution, where you've got a few, like just a couple systems and then a DNS host. Some of them are full-on production environments, and all of it is done using using containers rather than virtual machines. So I think it is battle tested. Like, these people seem to be doing great with it. I'm doing great with it. And as far as I can tell, no one else has ever tried that, and I don't know what it means. But at least there are a couple success stories here, and I think everyone else is just stuck on virtual machines as the distribution method of choice, which is bad because those suck. I do not enjoy spending like half my day setting up a lab environment with those. So that's all I got. In conclusion, I am against any kind of security improvements because that makes the world less fun. Any questions? You got it. Just gonna wait so the people on the internet can hear you. You could just like throw it for a high risk, high reward speed delivery mechanism.
A lot quicker. So slightly diverging from your talk about the benefits of Docker, I've done similar things using Vagrant images. With the advantage there is the Vagrant repositories are very crufty. And so it's often easy to find that CVE for a particular version of a file, and you can find a whole Vagrant image that already has that vulnerable version set up and running. So just a tip for those who might be looking to quickly and easily set up a vulnerable environment themselves.
Sounds good. That's awesome. And I'd love to ask you, I've looked at Vagrant, and my main reasons are if I did want to run a virtual machine that was not Linux, I couldn't really do that in Docker, but I wanted to run like a Windows host. You could do that with Vagrant easier because it does allow you to kind of mix containers and virtual machines. And what stopped me was just time and effort. I'm on those time budgets. Docker was the thing that like I could pick up and run super easily. Vagrant just took a little longer to the point where I'm like, it doesn't matter enough for me to spend extra time in it. Would you say that Vagrant is, if someone did want to like devote a day to trying to pick it up and build something like this, is that reasonable? Is that easy enough to pick up and do?
So the way I like to run Vagrant is I keep the operating system set up fairly minimal. So I have the Vagrant file that defines a particular image that you're going to start from. I generally, unless I've picked up an app that's deliberately vulnerable, right? But I generally start with one of the base operating systems, and then I have a shell script that goes ahead and does the rest of the install. And so that's a bootstrap file, right? So those can get fairly complicated just because I like to do all of that myself. But the infrastructure of Vagrant, I would say a day probably is sufficient. The big catch is deciding how you're going to run your networking setup. Host only versus exposed ports. And of course, Vagrant is calling a virtual machine manager, something like VirtualBox is generally what I use. And so there's some interactions there that you have to figure out. But I can also share with you, I've built an Active Directory environment in Vagrant, which it's up on GitHub, you could look at.
I'd love to see that. I'll hit you up after.
Am I a bad person if I view this entire talk and I substitute Honeypot for Class Lab?
This would be a great place for honeypots too, because yeah, it can be hard to tell if you are in a container unless you know what you're looking for. And I know the Cowrie honeypot, if you look it up, has just a default backend where they will stick you in a Docker container and just pretend like you logged in over SSH and see what you do. So yeah, good point. I should definitely have added that to the list of things to do with this.
Also on the point of, Docker versus VM for the sake of this and educational purposes, I think very specific or looser stuff with Docker is obvious and should be done more. And I love Docker and I want to do that. But I think systemd being one of the biggest ones and init, and how it's shared across, like that is, to my knowledge, a big reason why a lot of like Hack the Box and Try Hack Me, they keep them on VMs to be true to that part of the system. I know that is not necessarily true for all cases, but I think that is what I'm aware of, at least, for why they keep them on VMs, to be more true to the actual init process and systemd management stuff, right?
Yeah, that is a good point. And there have definitely been times when I've noticed little edge cases where the container is different than a virtual machine. One of them was like trying to send messages to other terminals. There was just like some weird container trick where it didn't work properly. I had to like add certain system files back in or make modifications. And that gets annoying for like most, I would say like application level developments, like anything, production network, CI/CD, any of that. I never noticed notable changes between container and virtual machine, but I'm sure, yeah, once you start diving into anything kernel related or anything like that, then yeah, it's virtual machines all the way.
Yeah. Anyway, I like the content.
Yeah, thanks for pointing that out.
Okay, I have one question, but by any chance, the kind of Docker configuration or any custom images you've made, are any of those available by any chance?
They are. I would not call them production ready because I did them the weekend before they needed to be done. So they were in a bit of a rush. But yeah, everything here is on GitHub. I would just not say it's in a perfect production ready state. Maybe give me another month.
Cool, thank you.
But if anyone is interested in those, hit me up. There were also some various like little hitches I ran into along the way, which I've skipped here because of more technical details for time reasons. But if anyone is actually planning on setting one of these up, especially for an interactive thing like a class, let me know, because you could just help find any of those in advance. One thing that I did find interesting but unexpected, I did not have time to really go fine tune all the permissions and make sure that users couldn't really screw with each other. And for this production environment, there were 200 people in this class. So even though it's 9 machines and that like runs great on a laptop, running 1,800 machines, it does actually strain my limits a little. And literally all of this, like the entire class was run off a single medium cloud instance, so it was not given that much space. So people could definitely like modify files that they shouldn't have been able to and leave messages to each other in files. And funny enough, 200 people, there were 0 issues of people breaking like core system files. I kind of assumed I would have to patch some of that on the fly. The worst people did was just leave little text messages in weird places like Wyatt was here. And then you'd just go and be like, hi, I'm Wyatt. I found this. Just leave your name if you did too. So oddly enough, most of the time, if people are given like enough content, they won't actively try to destroy anything until they run out of content and get bored, and then they'll try deleting Etsy. So, yeah.
Well, thank you very much. Let's give Alex another round of applause.